Thanks, Elena, for the nice introduction, and thanks for inviting me to give a talk. Yes, I'm Dilek Hakkani Tur. I am a research scientist at Amazon, and my team basically works on enabling conversational machines. I imagine most of you already know about Alexa and are talking to Alexa. So we are basically working Alexa to be more naturally conversational. And today I'll mainly be talking about social conversations with Alexa. But just to give a higher level overview, we do work on task-oriented conversations. So my team, these are all challenging AI fields. So we basically try to invent new algorithms that would enable these machines to be helping users, talking to them to handle their needs. So one type of interactions, one type of conversations that could happen with the users are task-oriented conversations. In this situation, we imagine users have a goal in their mind, like they would like to book a table at a restaurant, maybe they would like to call a cab, or they would like to buy movie tickets and so on. So I do have a sample task-oriented conversation on the screen. On the left, you see the user turns. On the right, hopefully the system turns. So in task-oriented conversations, oftentimes there's an API in the backend that could actually automatically do the intent, in this case, booking a table. Then what do conversations mean? The goal of the conversational system is basically talk to the user. First of all, understand their intent. Would you like to find a restaurant? Would you like to book a table? Would you like to book a cab and so on. The next part basically involves understanding arguments of these users' intent. So they may be looking for an upscale restaurant, which would imply maybe a certain price range. They may be looking for it. They may be specifying the date. They may be specifying the location. So then understanding by the computer side of these forms of utterances is basically taking the user utterances, extracting the arguments, and then formulating them as a call to the API in the backend, which would be given by a set of arguments and value pairs. There are also social conversations, as I mentioned in the very beginning. Here, there is no need for a specific API that could perform a task, but here, the goal is basically to engage in relevant and informative conversations with the users. So this could be things like talking about movies that they have just seen, exchanging comments about the movie, and so on. And I'll talk about these forms of conversations in more detail. Oftentimes, there is no backend API in these cases, but there is the enormous amount of data that is on the web where the conversational system can learn from and then come up with conversational suggestions. And the last area, and this is the topic for today, and the last area that we focus on is multimodal conversations. So in this case, the machine and the user are not just talking in natural language, but the machine can also, for example, see what the user is seeing, or the machine can provide visual information to the user. So the case where the machine can see, for example, could be human-robot interaction. And natural language is ambiguous. Oftentimes we give instructions thinking we have specified everything, but looking at the visual information, for example, in this case, user says, walk straight right before you reach the bed. Looking at the visual information, the robot may be confused because there are two beds in this situation. Then in that case, it should be able to ask questions. Where should I go? And the user should be able to answer it. So for this type of conversations, we don't just look at the language, we look at the multimodal visual information as well. So for social conversations, one of the projects that we have is Alexa Prize. And Alexa Prize is a global university competition. It's a multi-million-dollar challenge that Amazon has been organizing over the past 3-4 years. And basically, we do fund university teams to be able to build conversational systems. And Alexa customers, all of us, we can reach to one of these university teams by just saying, Alexa, let's chat. And then the customer will automatically be paired up with one of the university teams. So sorry, my Alexa kicked off inside. It's in a totally different room, but it's connecting to me to one of the university teams from inside. I'm hoping you guys are not hearing that. I should have muted it. But anyways, so what happens is the university teams try to engage users for a conversational, engaging interaction. And the grand challenge is basically getting a high score from the users. What happens is once the user's talking to Alexa, they can say, Alexa, stop. At that point, we ask to the users, at a scale of 1 to 5, what would the rate of rank, how would you rate this bot? And the grand challenge is enabling these systems to reach a score of 4 on average from the users and hold an engaging interaction with the users for about at least 20 minutes on popular topics. So we just finished the 3rd year of the challenge, and Emory University from Atlanta, Georgia, actually won the $500,000 prize. It was a student team of about 10 students and a faculty supporting them. And there were 10 teams from all over the world. We had one team from Czech Republic, and majority of them were from the US. And the second place winner was Czech Tech Republic from Czech Republic, Czech Tech University. And then the 3rd place was Stanford University. And during this challenge, scores of these bots have been improving. So on these plots, I do have x-axis is the time, and then y-axis is the average rating that the bots got from the customers. And these are the red and blue lines are the finalist teams, the best teams from the last 2 years of the competition. And as you can see, the scores have been improving on the overall. Now the teams are easily reaching a score of 3.6, 3.7 average per day. Similarly, for the durations of the conversations, again, x-axis is the time. Now y-axis is the 90th percentile conversation duration in seconds. As you could see, now we're about 12 minutes. Teams can hold easily 12 to 13-minute conversations with Alexa users. So what is happening in the background, and how are we helping these teams besides the funding and the resources? First of all, when users say, let's chat to Alexa, what first happens is automatic speech recognition. So Amazon provides speech recognition capabilities. We do recognize user utterances, and we do transition them to a set of tools that we have built. These are natural language processing tools. For example, we can understand if the user says something offensive, inform the team. They could come up with an appropriate response, or we could understand the topic of user's conversation. We extract named entities, we find dialogue acts, we find sentiments of the users, and so on. So each of these are built using machine learning methods. These are all models that we train from data that we gather through crowdsourcing and so on. And after this first language processing stage, the goal of the teams is to build they can build components in natural language processing, additional components, but their goal is, main goal is to build response generators. So now that we do have some notion of what the users are saying, they do build response generators and response selectors. They do build multiple response generators. We do provide them response generators as well. For example, Amazon has EV question answering system. We do provide answers from EV to them. We do have neural network based response generators, which I'll briefly mention at the end. We do provide them responses from those, and they do build their own response generators, for examples about movies, restaurants, and so on. And they also build a response ranker, meaning you cannot play all the responses to the users. You need to pick one, and they do build algorithms that would learn to select the best response from all the response generators. So after they generate the responses are just in text. But we do provide them text-to-speech synthesis capabilities so that the users can hear the response. And we do provide them ability to do markups on the text output so that they can generate lively speech by playing with the prosody of our text-to-speech synthesis system. And what do I mean by multiple response generators? So as I mentioned, we do provide them EV. User comes in and asks a question. Now we do want to answer that question. So teams usually build response generators for each domain, specializing each domain. A domain could be books, a domain could be movies, and so on. And they can stack our response generators as well, and then they do select one of these responses. And this has been the common approach by a majority of the teams. They oftentimes build and then add additional capability, like on sports, video games, fashion, and so on. Teams do benefit from the knowledge on the web in the forms of knowledge graphs or documents associated with the entities on the knowledge graph. So knowledge graphs are common representations for entities and their relationships. There are a few freely available knowledge graphs out there, like Wikidata, or they can build their own. And use of knowledge graphs enables them to easily switch from one topic to another one. So for example, if the user is talking about Paris, then they can easily mention as the next topic, oh, have you seen the Eiffel Tower, for example. They do use graphs for other purposes as well, but I'll just skip that for now. And so as I mentioned, utterance processing. So in addition to what we have been providing them, teams also do additional utterance processing. So that means the automatic speech recognizer, all it will give you is a sequence of words, sometimes with punctuation by using the prosody of the speech or the properties of the language, but oftentimes it is a monocase sequence of words. So teams do segment them into dialogue acts, which are like sentence-like units in speech. They do associate them with them categories, like this is a statement, the user is asking a question, the user is giving feedback, and so on. And they do mark entities, and then link them to the knowledge graph. So this will imply finding Spielberg and Jurassic Park and James Cameron and so on as special entities, and then linking them to special unique IDs that they have on the knowledge graph. And they do sentiment and emotion detection. So they do want to understand user sentiment towards the entity or the concept that is being discussed. And the goal here is to be able to demonstrate empathetic responses back to the user. If the user is not happy about something or they are sad, you would like to come up with an appropriate response and not to annoy them. So these are each of the processing that the teams are doing. And for generating responses, a lot of the teams are building models. They are also building flow charts of dialogue responses. And my team basically works on neural network models for response generation. So basically, given a conversation context, we try to learn neural networks that would learn to generate a response. So this has been work in this, there has been work in this area. This is mainly modeled as a translation problem. That's how we do it as well. We translate from the conversation context or knowledge to the next response. Most people use encoder-decoder networks, And most people look to fine-tune pre-trained language models. So the most popular approach is training large language models these days with the amount of data available on the web, which you can fine-tune to the task at hand. And we do use GPT-2 provided by OpenAI. And finally, you don't just want to generate responses that do not fit in the context or what the user is talking about, or you do not want to mislead the users. So what we do is knowledge-grounded response generation. So once we find the entities, we associate them on the knowledge graph. What we do is we bring relevant knowledge about those entities, like, for example, Wikipedia documents, fun facts about these entities, news stories about these entities, and so on. And here's how it would look like. These are the facts or Wikipedia article that we have about the topic that the user is talking. And our goal would be, assume we are given the first 3 turns of the conversation. Our goal would be generating this 4th turn. And our models are basically learning how to appropriately respond to this context, plus how to copy relevant or important information from the knowledge to the conversational responses, so that we do not mislead the users, but we also come up with engaging and interesting topics. So that's basically it. Thanks for listening, and I'm happy to answer if you guys have any questions.
Brilliant. Thank you so much, Dilek. So we're looking at the chat at the moment just to see if there are any questions from teenagers. But before we dive into those questions, could I please ask you to share with us your story? How did you start, and how did you get into data science to begin with? Because for me, every story has got so many incredible, takeaways, particularly for the young women who are, willing to join the careers in data science and AI.
Sure, happy to talk about it. So I did my undergraduate degree in computer science, but I was always interested in language, even before going to college in computer science. It's like high school, middle school, you do learn other languages, right? I realized I'm not really very good in learning other languages. So all of this time I was thinking, like, why do we have to learn it? Why can't we have machines actually do the translation? Because each language has their special properties. My elective was German, and my native language is Turkish. I did learn English at school, but the elective language was very difficult for me because it does have articles and then genders. There's no gender in Turkish language, basically, when it comes to nouns and concepts. So it was very difficult for me. So when I started college, I'm very interested in computer science, but I kept thinking about language. And when I graduated, I thought, it's an area, I learned it's an area. I didn't know that natural language processing is an area before. I decided to do my master's and my PhD in language processing. And that's how it all happened, basically. Originally, I was very interested in just translation, but it turned into a passion towards making machines conversational. Because if you can make conversational machines, they can help you with so many things. Current devices do help with certain things. They're very helpful. We cannot just give up on them that easily. But I do want them to be able to do more, help us more, and so on.
Brilliant. And what did you like to study when you were in school, when you were in high school, for instance? What was the subject that you were really passionate about, and why?
Math.
Math?
Yes. Yeah, I like math for some reason. I don't know, but I'm really, really passionate about math.
Math is amazing. Can you describe?
I got excited about geometry first. It's very cool. Then calculus. I didn't know, like, to tell you the truth, when we were learning about the integrals and derivatives, I was thinking, like, this is sort of cool, but what are the real applications of them? And these days, with the neural network-based approaches, I do know the applications very well.
So those young people who really want to get into data science and artificial intelligence, what advice would you offer them? Some of them are still in school. Some of them are wondering what subject should I take, to get into careers in AI and data science. What advice would you offer to them, Dilek?
Mhm. I do. I mean, I do. Math is very important for computer science in general, and I do suggest, like, if you like, strongly focus on it. But at the same time, if you have a subject of passion, like my daughter is a teenager, she loves music, right? But she likes math and computer science as well. So computer science is this flexible field where it has applications everywhere. You can apply AI to, for example, creativity, towards arts, towards music, and so on. You could apply, like, if you're very interested in health, you could apply it to health applications, right? If you're very interested in languages, translation, you could have applications in computer science for language and so on. So I would say, if you do like something, don't give up on it, because oftentimes people do really good if they feel passionate about the things that they are working on. That would
Brilliant.
be like my number one advice.
Yes, find your passion, follow your passion, and
Exactly.
yes, and if it involves computer science as well, that's a bonus, right?
Yes,
Fantastic.
exactly.
Brilliant. And talk to me about how you ended up in Amazon as well, and why Amazon. What is it about Amazon Alexa that you are excited about? Because I remember I met the founder of, or the person who designed the algorithm, Evie. So
Hmm.
here in London, and he came to visit us during the very first AI accelerator.
Oh, fantastic.
And I remember he brought with him the very first version of Alexa, and my teenage girls were the first ones to test it in August before it became available on Amazon in October, I think, for UK market.
Mm.
So, and obviously I'm speaking about William Tunstall-Pedo, who obviously is no longer with the company. He is highly influential in the space of AI, particularly voice, but he no longer is with the company, but often speaks in keynotes and conferences. So we had a real
Mhm.
pleasure speaking to him, how it all started and where it all led. So what excites you about Amazon Alexa?
Yeah, I did. I mean, throughout my career, I did work on multiple research labs. I did work on at the final stages of AT&T Bell Labs, Microsoft Research, Google Research, a research lab at UC Berkeley before joining Alexa. And now Amazon. I do teach at UC Santa Cruz at the same time. So I guess I do follow wherever it is, the topic is really well studied, easily studied. And for systems like conversational systems like Alexa, it is very important to have lots of users, to have lots of data. Oftentimes, you learn from the data, or you need to know what you need, how you can extend the capabilities of the system, or where the system is failing. So data is very important, especially conversational AI is a very applied field. So that's basically what drives me to Amazon, because we do have millions of users talking to Alexa every day, and my passion is to make it much better in handling all forms of user requests. So I feel like it is the place to be if you do want to work in this field. That's what drew me to Amazon.
Amazing, brilliant. So we do have a couple of more questions, and they are from the teenagers. I'm going
Great.
to ask them now. So we have one asked by Emily, related to Alexa actually this time. How do you deal with words that can have different meanings depending on the context?
Yes, very fantastic question. Words are ambiguous and they can have different meanings. So, two ways. One of them is using as much information from the context as possible. And then context, it could be the user, what just said around that word. that is ambiguous, right? And what the user said before in the previous word, in their previous turn, and so on. This form of contextual information usually helps us to disambiguate. But you could say that, well, there are still things that are ambiguous. But the beautiful thing about conversational machines is if they cannot figure out what that word is, they can come back and ask, did you mean 6 a.m. or 6 p.m.? Well, if it is booking a table for dinner, from the context, from the rest of the utterance, if they say at 6, you can guess this is 6 p.m., but not 6 a.m., right? But if they just 6 without saying anything else, like even book a table, then you may ask them, like, what do you mean? What do you mean by 6? That's always possible. That's, I think, the beauty of dialogues, conversations.
Brilliant. And we have one last question, also from teenagers. Do you have to build replies from letters, words, or snippets, or a mixture of the above? And the second question is, are you only developing this in English or other languages as well?
Yes. Okay. Fantastic questions again. So it's basically a mixture. So we do certainly have templated approaches that do use snippets. We do also have more machine learning based approaches that would generate words or word segments that are stitched together to come up with the overall utterance. So we do have a mixture of these approaches. And other languages, yes, absolutely. So currently we do have Alexa in multiple languages, and there is a continuous effort to extend the number of languages that Alexa covers, so that we could help more people with their requests.
Brilliant, brilliant. No, fantastic. And thank you so much, Dilek, for this incredible insight into your career and all the advice you have offered. So thank you everyone who tuned in live for all your incredible questions. We have 2 more speakers today, and we will be letting Dilek go. Thank you very much once again for joining us, Dilek, and have an amazing rest of the day. So
Thank you very much. Thanks for listening and inviting. Thank you. Bye-bye.